Good morning, everyone. We're going to work on worksheet 15 today. As the first example, determine the linear approximation for the function root 3 of x and use the linear approximation to approximate these two radicals. As we have the formula L of x equals, this is for approximation, f, the function of the point that we know the answer for that or close to the one that we are going to find, plus f prime of that times the difference between the one that we know the answer and the one that we are going to find the answer. So in here, f of x is root 3 of x, and we can write it as x to the power 1 over 3 to take derivative. So f prime of x would be 1 over 3 x to the power 1 over 3 minus 1, which is negative 2 over 3. And we can rewrite it as 1 over 3 root 3 of x squared. Now, thinking of root 3 of 29, we know that in this one, x would be a number that is close. Okay, so when we say root 3 of 29, we're going to say that x is 29. And think of a number that is close to 29, and we know the root 3 of that. That would be 27, because we know that root 3 of 27 is 3. So we would say a is 27 here. Now, we're going to find f of a. We know that f of x is root 3 of x, so f of a would be root 3 of 27 plus f prime at a. F prime is 1 over 3 root 3 of 27 squared times x minus a, which is 2 here, 29 minus 27. Now, what is root 3 of 29? It will be root 3 of 27, which is 3, plus 1 over 3 times root 3 of 27. So for finding root 3 of 27 squared, we can rewrite it as root 3 of 27 totally to the power 2. We know that inside the parentheses is 3 and we have square here. So this one would be 9, but we have a 3 next to it. So 3 multiplied by 9 will be 27. And we know that this one is 2. Using calculator, root 3 of 29 will be approximately 3.074, which makes sense because 29 is a little bit more than 27. So we expect that root 3 of 29 be a little bit more than 3. So for the next one, which is root 3 of 8.05, we're going to use the same formula, but with different numbers. Think of a number close to 8, which we know close to 8.05, which we know the root 3 of that number. We know that we already know what root 3 of 8 is. So we're going to use the formula again, but this time we're going to find root 3 of 8.05, and we're going to find f of a. So in this case, the number that we are going to find is 8.05. So x would be 8.05. And the number that we know the amount is just 8. So f of a would be root 3 of 8 plus f prime will be 1 over 3 times root 3 of 8 squared times the difference of 8 and 8.05. So it is 8.05 minus 8, which is 0.05. So root 3 of 8.05 is 2 plus the same idea here, 1 over root 3 of 8 squared is the same as root 3 of 8 totally squared. We know inside the parentheses is 2 to the power 2 will be 4. And we have a 3 here, so altogether we would have 1 over 12 times 0.05. And using calculator, it will be approximately 2.004, which makes sense because it will be a little bit more than root 3 of 8, which is 2, so a little more than 2. Let's move on to the next question. Number 2, considering the linear approximation for f of x. Okay, this is number 3. Number 2 here. Determine the linear approximation for f of x equals sine of x and use linear approximation to approximate sine of 32 and 176. Okay, same formula, L of x equals f of a plus f prime of a times x minus a. And we know that f of x is sine of x, and so f prime of x would be cosine of x. And x here for the first one, which is sine of 32, is the one that we already know the sine, which is 30 degrees Celsius, and a would be 32 degree. So sine of 32 degree will be f of a, which is sine of 30 degree, plus f prime of that, which is cosine of 30 degree, times x minus a. We know that x minus a is 2 degree, but in trig functions, we're going to use radian because all these concepts are in terms of radian in trig functions. And we know that 1 degree is the same as pi over 180. So when we have 2 degrees, in order to translate it in terms of radian, so you would write 2 times pi over 180. After simplification, we would have pi over 90. So we're going to use this. Pi is just pi in your calculator. So it will be pi over 90 here. So sine of 32 degree will be sine of 30, which is 1 over 2, plus cosine of 30, which is square root of 3 over 2 times pi over 90. And using calculator and using the button pi, not something rounded like 3.14 or something like that, just press pi for that. It will be approximately 0.53, which makes sense because sine of 30 is 1 over 2, which is half. So it is a little bit more than that. For the next one, which is sine of 176, So again, we're going to think of a number near that. So in this case, x would be 180 because the closest number to 176 that we know the sine and cosine is 180. So a would be 170. Excuse me, this is a, this is x. 176. X is the one that we're going to find. So what is x minus a? It is 176 minus 180, which is negative 4. We know that 1 degree is the same as pi over 180. So negative 4 degree will be negative 4 times pi over 180 if you want to write it in terms of radians. So if you simplify 4 and 180, it will be pi over 45 radians. So sine of 176 degree will be sine of 180 degree plus cosine of 180 degree times x minus a, which is negative pi over 45. So sine of 176 degree is sine of 180 is 0 plus cosine of 180 is negative 1 and times negative pi over 45. Again, using calculator, we're going to find the answer as 0.07, which makes sense. Let's move on to the next one. Number 3. Consider the function f of x equals x ln of x. Find the differential dy and evaluate dy and delta y if x is 1 and dx is 0.1. So we have the formula that says dy equals f prime of x times dx. Following this formula, dy will be, so in here we know that f of x is x ln of x, but what is f prime of x? Following product rule, we would say copy the first one, derivative of the second one, plus copy the second one, derivative of the first one. And after simplification, we would have 1 plus ln of x. So instead of f prime of x, we would write f prime of 1 times dx. dy is, what is f prime of 1? If you plug in 1, you would get 1 plus ln of 1 times dx, which is 0.1 according to the question. So dy would be, we know that ln of 1 is just 0, so altogether we would have 0.1 as the answer for dy. Next one is delta y, which is f of x plus delta x minus f of x. So delta y will be, in here we know that delta x is the same as dx. So f of 1 plus 0.1 minus f of 1. We know that f of x is x ln of x. So we have delta y equals f of 1.1 minus f of 1. It will be delta y equals ln of 1.1. Oh, excuse me. 1.1 times ln of 1.1 minus f of 1, which is 0 because it is ln of 1, which is 0. So using calculator, you would get 0.105 as the answer. As you see, these are approximately the same. We know that delta x is the same as dx, but delta y is approximately the same as dy. Okay, number 4 follows the same formulas. So number 4, same question with different function. For finding dy, we would say it is the same as f prime of x dx. So dy is, we know that f of x is root 2 of 1 plus x squared. So f prime of x will be 1 over 2. Okay, let's think of this way. F of x is 1 plus x squared to the power 1 over 2. So f prime would be 1 over 2 times 1 plus x squared to the power 1 less, which is negative 1 over 2, times the derivative of the inside, which is 2x. So after simplification, we would have f prime of x equals x over root 2 of 1 plus x squared. So f prime of 2 here times dx, which is 0.05 according to the question. So dy would be f prime of 2 is 2 over 1 plus 4 times 0.05. So using calculator, you would get 0.045, which is dy. Now we're going to find delta y. As before, delta y is f of x plus delta x minus f of x. We know that x is 2, delta x is the same as dx, which is 0.05. So delta y would be f of 2 plus 0.05 minus f of 2. So delta y equals f of 2.05 minus f of 2. Delta y will be f of 2.05 is square root of 1 plus 2.05 squared minus f of 2 is root 2 of 1 plus 2 squared. Now, using calculator, you would get 0.0448, which is approximately equal to 0.045, which we found for dy, and we expect this one. Okay, let's move on to number 5, which is about antiderivative. So for a couple of questions, we're going to find antiderivative. For the first one, the easiest way to find that is to FOIL it for the first step and then find antiderivative. So if we FOIL, we would have x squared minus x minus 2. Now we're going to find capital F as the antiderivative. Just as a recall, when you have x to the power n as f of x, which is the derivative, you would have capital F of x as antiderivative as the power 1 more over the same number plus a constant like c. So following this formula, we're going to have x power 3 over 3 minus x power 2 over 2 minus 2 times x, because when you have nothing here, that's x power 0, and you would add 1 to it, plus the constant c. And it cannot be simplified. Number 6, again, we're going to find it first, expand it, simplify it, and then find the antiderivative. So it will be x squared plus 2x plus 1. And after multiplying x to it, we would get x cubed plus 2x squared plus x, and then we're going to find antiderivative, which is x to the fourth over 4, following the formula that we already talked about, plus 2 over 3 x power 3 plus x squared plus over 2 plus the constant c. Okay, next one, next page. First one, you may think of, okay, this is e to 2, so we would add 1 to the power. But think of e, it is a number. A number to the power 2 is also a number. For all numbers, they are constant. And for constants, we would just multiply it by a variable. So you would treat this question as if you had like 5. What is the antiderivative of 5? That's 5x. Same idea here because x squared is the same as um, a number. Number 8. The easiest way to do number 8 is just to rewrite it first as a power. We know that this is 3 over 5. And the second one is x to the power 5 over 3. So in order to find antiderivative, we're going to say the power plus 1 over the same number. Don't rush to find the answer. Just write it this way and then simplify. 5 over 3, 5 over 3 plus 1 plus a constant. Okay, now we simplify. We would say that it is 8x to the power 8 over 5 over 8 over 5 plus x power, okay, this one is plus 1. 8 over 3, 8 over 3 plus c. And you may like to rewrite it as 5 over 8 root 5 of x power 8 plus 3 over 8 root 3 of x power 8 plus c. Number 9. We know that x square root of x is the same as power 1 over 2. So we would write it this way and then find antiderivative would be keeping the coefficient here. The power will be added. Okay, so this is 2 plus 1 over 1 over 2 plus 1, 6 as the coefficient. Keep it here, and antiderivative of cosine is sine of x plus the constant c. After simplifying, you would get 4 over 3 square root of x cubed plus 6 sine of x plus c. Number 10. Um, Again, the easiest way is just to rewrite it as 1 over x cubed, x over x cubed, x squared over x cubed. And simplify it. 1 over x squared minus 1 over x. We can rewrite it as x power negative 3, x power negative 2, and x power negative 1. This way we would find the antiderivative easier. So it will be f of x, x negative 3 plus 1 over negative 3 plus 1, x negative 2 plus 1, negative 2 plus 1. But as we remember, we cannot, okay, this one is a negative. So we cannot write x power negative 1 plus 1 over negative 1 plus 1 because it will be x power 0 over 0, which is undefined. So we had a formula for this one, which says whenever you have ln of x, the derivative is 1 over x. So reading this formula from right to left says antiderivative of 1 over x is ln of x. So the last part will be ln of absolute value of x because it shouldn't be negative. And you can rewrite it as negative 1 over 2x squared, negative 1 over x, and negative ln of absolute value of x plus c. Number 11, e to negative 2 times r. Remember, in this case, r is the variable because we have f of r as we have f of x usually. So capital F of r will be negative 1 over 2, a copy of it, plus c. Because if you take derivative of this one, you would get e to negative 2r as the answer. We will continue solving the problems in next video.